Viewers at home, you are welcome to the part 2 of my presentation on time series analysis. In this part 2, I will examine the linear regression method of solving time series analysis. The following shall be covered in this part 2. Number 1, meaning of linear regression. Meaning of linear regression. Steps for solving time series using linear regression method. 3. Estimation of seasonal variation. Estimation of seasonal variation. Number 4, I will provide 2 practical work examples. If you are just coming across this YouTube channel for the first time, or if you have not subscribed in the past, please click the red subscribe button and also turn on the notification bell icon so that you don't miss my upcoming videos. If you are a returning subscriber, I say thank you and God bless you. What do you mean by linear regression analysis? Linear regression analysis is the technique that produces a line of best fit for the observed data. The technique that produces a line of best fit for the observed data. Linear regression, this is the technique that produces the line of best fits for the observed data. In part 1 of this presentation, 2 different models were examined. Number 1, additive model. Additive model, from the word addition. So we have additive model, y equals to trend plus cyclical seasonal variation plus cyclical variation and plus random variation. Of these 4 variables, the first 2 variables are the most important one. T stands for trend, S for seasonal variation, C for cyclical variation, and R for random variation. And I've told you that of these 4 variables, the first 2 ones are the most important ones. The first 2 variables are the most important ones. When should we use the additive model? An additive model should be used when the seasonal variation are in number. When the seasonal variation are in number, when they are in amount, it is then that the additive model should be used. But where the seasonal variation is in percentage, then multiplicative model should be used. So I've told you that of these 4 variables, the 2 important ones are the first 2. That means you'll be having y equal to t plus s if you eliminate the last 2 variables. So the second model is the multiplicative model. Multiplicative model or proportionate model. Multiplicative model, we have y equal to t times s times c times r. And I've told you that multiplicative model should be used where the seasonal variation are in percentage. Whenever the seasonal variation are in percentage, then multiplicative model should be used. So, of of these four variables, the two important ones are t and s. Therefore, the model can be further be modified as y equal to t times s. So these are the four variables. These are the models for solving time series analysis using linear regression method. So what are the steps for solving time series using linear regression method? What are the steps for solving time series using linear regression method? Step number 1. Determine the trend equation. The first step is to determine the trend equation. Determine the trend equation. That is the first step. You determine the trend equation. So where this is not given, that is, where the trend equation is given, you don't need to determine that. It is only where the trend equation is not given that you will need to determine the trend equation. And the trend equation, we have it as the trend equation. We have it as y equal to a plus bx. Y equals to a plus bx. Where b equals to n summation xy minus summation x summation y over n summation x square minus summation x all in square. B equals to n summation xy minus summation x times summation y over n summation x square minus summation x all in square. And a, to determine the value of a, you have a equals to summation y over n minus b summation x over n. That is the first step. The first step. So what is to determine the trend equation? Y equal to a plus bx. So by the time you get the value of b and a, you now substitute for a and b in this equation in order to derive the trend equation. You now substitute the value of b for b. You now substitute the value of a for a in this trend equation. Step 2. Step 2, estimate the trend value. Estimate the trend value. Remember, in step 1, you have determined the trend equation. Trend equation has been determined. This trend equation will now be used to estimate as trend value using the trend equation. So you are going to estimate the trend value using this trend equation. Using the trend equation determined in step 1 above. You estimate the trend value using the trend equation determined or established in step 1. Then the third step, step 3, is to calculate the percentage variation of each quarters. Calculate the percentage variation or variations of each quarter of each quarters. Calculate the percentage variation of each quarters. So that is the third step. And to calculate the percentage variation, we have percentage variation equals to actual sales. Actual sales over the trend value. Remember, you have determined the trend value in step 1. So you now put the actual sales we are given in the question. You now put it over the trend value you have determined in step 2. Then multiply by 100 over 1. That will give us the percentage variations. That is the third step. The step 3 is to determine the percentage variation. Step 4. Step number 4. You calculate the average percentage variations. Calculate the average percentage variations determined in step 3. In step 3 above. The percentage variation you have determined in step 3, you are going to average it. The percentage variation you have determined in step 3, you average it. That is step 4. Now, this step 5, which is the last step, is to prepare the forecast. Prepare the forecast. You prepare the forecast. Your forecast will be equal to trend times percentage seasonal variation. Percentage seasonal variation. That is the steps. These are the steps for solving time series problem using linear regression analysis method. So now the example number 1. The following details were provided for the 4 quarters of the years 2021 to 2024. We have sales of widgets in thousands. We have quarter 1, quarter 2, quarter 3, and quarter 4. We have for year 2021, 2022, 2023, and 2024 respectively. These are the sales for each of the quarters of the years 2021 to 2024. Required. Use the above details to estimate A. the trends and seasonal variations of the sales of the widget. B. assume the seasonal variations is expected to continue in the future. Make the sales forecast for the 3rd and 4th quarters of the year 2025. That is the question. I have given you the steps for solving problems involving time series using linear regression analysis method. I've told you that this first step is to estimate or determine the trend equation. I've told you that the trend equation is provided by y equal to a plus bx. So, you are given different years in the question. We have 2021 to 2024 for quarter 1 to quarter 4. Now, let's have 2021. So, 2021. Let me have years. X, we have 1, 2, 3, 4, 5. This is quarter 1, quarter 2, quarter 3, and quarter 4. This is for 2021. Quarter 1 to quarter 4. Then we also have year 2022. 2022, we have 5. Just start from where this one stops. You don't need to start from 1 to 4 again. We have 5, 6, 7, 8. This is 2022. Then 2023 again. You don't need to start from quarter 1 again. Just start from where this stops. We have 9, 10, 11, 12. Then 2024. Just start from where this stops. We have 13, 14, 15, and 16. Now, you are given the sales for each of the quarters. Sales is given for each of the quarters. Let me know that by y. Now, back to the question. For quarter 1, we have 20, 32, 62, and 29. So we have 20, 32, 62, and 29. That is for 2021. Then 2022 again, we have 21, 42, 75, and 31. We have 21, 42, 75, and 31. Then 2023 again, we have 23, 39, 77, and 48. So we have 23, 39, 77, and 48. Then we have 2024. We have 27, 39, 92, and 53. 27, 39, 92, and 53. These are the sales for each of the quarters. And remember, all amounts are in thousands. All amounts are in thousands. So you need to sum up this. You sum up 1 to 16. Now, 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10 plus 11 plus 12 plus 13 plus 14 plus 15 and plus 16. The total is 136. Then you also sum up this column. We have 20 plus 32 plus 62 plus 29 plus 21 plus 42 plus 75 plus 31 plus 23 plus 39 plus 77 plus 48 plus 27 plus 39 plus 92 and plus 53. The total is 710. 710. And remember, I've told you that the trend equation is provided by y equals to a plus bx. Y equals to a plus bx. That is the trend equation. And I've told you that to estimate the value of b equals to n summation xy minus summation x summation y over n summation x squared minus summation x all in square. So by virtue of this formula, you will need the summation of x and y. Xy means x times y. X times y. So that means you will need the product of x and y. Now let's create a column for that. X, y. X, y means x times y. So you cannot have 1 times 20, and that is 20. 2 times 32, that is 64. 3 times 62, that is 186. 4 times 29, and that is 116. 5 times 21, that is 105. Then 6 times 42, that is 252. 7 times 75, that is 525. Then 8 times 31, and that is 248. 9 times 23, 9 times 23, that is 207. 10 times 39, and that is 390. 11 times 77, and that is 847. 12 times 48, and that is 576. 13 times 27, and that is 351. 14 times 39, and that is 546. 15 times 92, and that is 1380. 16 times 53, and that is 848. Then you equally sum it up. Now let's sum up that. 20 plus 64 plus 186 plus 116 plus 105 plus 252 plus 525 plus 248 plus 207 plus 390 plus 847 plus 576 plus 351 plus 546 plus 1380 plus 848. Total is 6,661. 6,661. Back to the formula. We've got our summation xy. We've known our summation x. Summation s is this, 136. We've equally known the summation y. Our summation y is 710. Then we've not known x squared. Now, let's create a column for x squared. X squared. So x squared, 1 squared is 1. 1 squared is 1 times 1. 2 squared is 4, that is 2 times 2, that is 4. 3 squared is 9, that is 3 times 3, that is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared, and that is 81. 10 squared is 100. 11 squared, which is 11 times 11, which is 121. 12 squared is 144. 13 squared is 169. 14 squared is 196. 15 squared is 225. And 16 squared is 256. So we also sum it up. So we have 1 plus 4 plus 9 plus 16 plus 25 plus 36 plus 49 plus 64 plus 81 plus 100 plus 121 plus 144 plus 169 plus 196 plus 225 plus 256. And that is total 1,496. 1,496. That is the summation of x squared. Having provided the necessary variables, so we therefore want to estimate the value of b. We want to estimate the value of b. So our n, there are 16 variables there. That means our n is 16. Now back to the formula. We said b equals to n summation xy minus summation x summation y over n summation x squared minus summation x all in square. And our n is 16. There are 16 items altogether times summation xy. Now, this is xy column. Summation xy is 6,661. 6,661. We have 16 times 6,661 minus summation x and summation y. This is x column and this is y column. Summation x is 136 and summation y is 710. So we have 136 times 710 all over n. Our n is still 16 since there are 16 items altogether. 16 times summation x squared. This is the column for x squared. So summation x squared is 1,496. 1,496. So we have 1,496 minus summation x. So that means you are going to use x. Summation x. This is x column. So summation x is 136. So we have 136. Summation x all in square. So we now have 16 times 6,661. And that gives us 106,576. 106,576 minus 136. 136 times 710. 136 times 710, you have 96,560 over 16 times 1,496, and that gives us 23,936 minus 136 square, and that gives us 18,496. 18,496. So we now have 106,576 minus 96,560. That gives us 10,016. 10,016 over 23,936 minus 18,496, and that gives us 5,440. So if you now divide 10,016 divided by 5,440, then you have 1.84. Therefore, our B is approximately equals to 1.84. We've estimated the value of B. Having estimated the value of B, and I've told you that the trend equation is provided by y equal to a plus bx. So we therefore need the value of a. And I've told you that a equals to summation y over n minus b summation x over n. As summation y, you go back to the equation. The variables. Summation y is 710. We have 710, and we still have 16 items altogether. We have over 16 minus b, and our b is 1.84 as determined. So times summation x. Summation x is 136. 136 over n. The item is still 16. So we have 710 divided by 16. 710 divided by 16, then you have 44.375 minus 1.84 times 136 divided by 16. That gives us 15.64. If you subtract 15.64 from 44.375, then you have 28.735. Therefore, A is approximately equal to 28.74. Now, we've determined the value of A and the value of B. And I've told you that the trend equation is y equal to A plus bx. You now substitute for A and B in the trend equation respectively. Our A is, we have y equal to A, which is 28.74 plus B, and our B as determined or calculated is 1.84. We have 1.84x. That is the trend equation. That is the first step. The second step is to determine or estimate the trend value. Using the trend equation, we want to estimate the trend value. Now, and remember our trend function. We have y equal to 28.74 plus 1.84x. So that is our trend. So we want to estimate our trend. Our trend, we have trend, which is y equals to 28.74 plus 1.84x. When x is 1, where x is 1, so that means you'll be having y equal to 28.74 plus 1.84 times 1. So if you have 1.84 times 1, it will still be 1.84. 1.84 plus 28.74, and that will give us 30.56. So 30.56. So that is our trend equation. 30.58. 30.58. Then where x is 2, So you substitute 2 for x. That means you have 28.74 plus 1.84 multiplied by 2. So where x is 2, 1.84 times 2. If you have 1.84 times 2, that will give us 3.68 plus 28.74. That gives us 32.42. That is our trend equation. That is our trend value for that. Then when x is 3, you substitute 3 for x. So, and that will give us 34.26. And when x is 4, that will give us 36.10. When x is 4, we have 36.10. And when x is 5, if you substitute 5 for x, so you have 37.94. 37.94. And when x is 6, if you substitute 6 for x in this function, then you have 39.78. 39.78. And when x is 7, if you substitute 7 for x in that train function, so you have 41.62. 41.62. Then when x is 8, then you have 43.46. And when x is 9, then you have 45.30. And when x is 10, if you substitute 10 for x in our train function, you have 47.14. 47.14. And when x is 11, if you substitute 11 for x in our train function, you have 48.98. 48.98. Then when x is 12, if you substitute 12 for x in our train function, you have 50.82. 50.82. And when x is 13, if you substitute 13 for x, then you have 52.66. 52.66. And when x is 14, then you have 54.50. And when x is 15, then you have 56.34. And when x is 16, then you have 58.18. That is our trend value. Having estimated the trend's value, then remember in the requirement A, you have to estimate the trends and seasonal variations of the sales of the widget. So that means the next thing is the determination of the seasonal variations. So, seasonal variations. Seasonal variations. Seasonal variations is calculated by dividing the actual sales by the trend value times 100. Now, actual sales in the first quarter of the year 2021 is 20, and the trend value is 30.58. 20 divided by 30.58 times 100 over 1. If you have 20 divided by 30.58 times 100, and that will give us 65%. The second quarter of the year 2021, actual sales is 32, and the trend value is 32.42. So we have 32 divided by 32.42 times 100, and that will give us 32 divided by 32.42 times 100, and that gives us 32 divided by 32.42 times 100. Then we have 99%. 99%. Then the third quarter of the year 2021, we have 62 divided by 34.26. That gives us 181. By the time you calculate it in percentage, 181%. Then 29 divided by 36.10, then we have 80%. 80%. Then 21 divided by 37.94, then we have 55%. Then 42 divided by 39.78, we have 106%. 75 divided by 42 divided by 41.62 times 100, then we have 180%. 180%. Then 31 divided by 43.46 times 100, we have 71%. Then if you have 23 divided by 45.30 times 100, we have 51%. Then 39 divided by 47.14, we have 83%. Then the seasonal variation, if you divide 77 by 48.98 times 100 over 1, and that will give us 157%. If you have 48 divided by 50.82 times 100, that gives us 94%. Then if you divide 27 by 52.66 times 100, that gives us 51%. The seasonal variation obtained when you divide 39 by 54.50 times 100 will be 72%. Then if you have 92 divided by 56.34 times 100, that gives us 163%. Then if you divide 53 by 58.18 times 100, that gives us 91%. Now, that is our seasonal variation. So, calculation of seasonal variation. Calculation of seasonal variations. We have the years 2021, 2022, 2023, and 2024. And we have the quarters. Quarter 1, quarter 2, quarter 3, and quarter 4. Then, in quarter 1 of 2021, our seasonal variation is 65%. 65%. Then we have 65%. In quarter 2, we have 99%. 99%. In quarter 3, we have 181%. 181%. In quarter 4, we have 80%. 80%. In year 2022, quarter 1, we have 55%. 55%. In quarter 2 of 2022, we have 106%. 106%. In quarter 3, we have 180%. 180%. In quarter 4, we have 71%. 71%. Then we have year 2023. Quarter 1, we have 51%. 51%. Then in quarter 2, we have 83%. 83%. In quarter 3, we have 157%. 157%. Then the next one is 94%. 94%. Then in 2024, we have 51%. 51%. Then the next one is 72%. 72%. Followed by 163%. 163%. Then followed by 91%. 91%. Then you now total it, you sum it up. What is the total? Total. We have 65 plus 55 plus 51 plus 51. We have 222%. Then we have 99 plus 106 plus 83 plus 72. And that is total 360%. Then 181 plus 180 plus 157 plus 163. Then we have 681. Then we have 80 plus 71 plus 94 plus 91. And that is total 336%. Then you now average your seasonal variation. You average it. And remember, we have 4 quarters. 4 quarters and 4 years. The number of years are 4. Since we have 4 years, to average it, you divide it by 4. Since there are 4 years, you divide it by 4. So you have average your seasonal variation. Average. That is, you divide it by 4. So that will give you the average. So 222 divided by 4, that gives us 56%. 56%. Then 360 divided by 4, that gives us 90%. 681 divided by 4, that gives us 170%. 336 divided by 4, that gives us 84%. 84%. So, now, back to the requirement. Assume the seasonal variations is expected to continue in the future. Assume the seasonal variations is expected to continue in the future. Make the sales forecast for the 3rd and 4th quarters of the year 2025. If you go back to this, you have this ended in 2024. That means in 2025, the The first quarter will be 17. The second quarter will be 18. The third one will be 19. And the fourth one will be 20 of the year 2025. That means the value of X will be 17, 18, 19, and 20. But you are to make the sales forecast for the third and fourth quarters of the year 2025. So the third and fourth quarter, the third quarter will be 19 and the fourth quarter will be 20. Therefore, you now go back to your trend equation. And what is our trend equation? You want to make a sales forecast. You want to make sales forecast for the first one is third quarter of year 2025. And the third quarter, we said the value of X will be 19. The value of X will be 19. Remember this one, we stopped at 16 in 2024. And in 25, the first quarter is 17, the second quarter 18, the third quarter is 19, and the fourth quarter is 20. So that means the value of X for third quarter is 19. Now, our trend equation we have determined in step 1 is y equal to 28.74 plus 1.84x. This is our trend equation. You are now going to make use of our trend equation y equals to 28.74 plus 1.84x, where x equal to 19. Our x is 19. You now substitute 19 for x in our trend equation. You substitute 19 for x, being the value of x for the third quarter of the year 2025. So we now have 28.74 plus 1.84 times 19. So we have 28.74 plus, now if you have 1.84 times 19, that gives us 34.96. If you add 34.96 to 28.74, then the total will be 63.7. Therefore, y equal to 63.7. Now, you now adjust. The next thing is to adjust for the seasonal variation. You adjust for the seasonal variation. Now, let's adjust for our seasonal variation. Seasonal variation. And I've told you that where the seasonal variation is in percentage, multiplicative model will be appropriate. And where the seasonal variation is in value, additive model will be appropriate. So, we want to make the forecast sales for the third quarter of the year 2025. Forecast sales now. Remember, in the third quarter, the seasonal variation is 170%. So you now calculate 170% of the sales or the trend value, which is 63.7. So now let's calculate 170% of that. Then we have 108.29. That is our forecast sales units. Since the amount is in thousand, then you can multiply it by 1,000. Then you have 108,290 units. That is our forecast sales for the year 2020, for the third quarter of the year 2025. Then the next one is the forecast sales for the fourth quarter of the year 2025. Remember, the value of x for the fourth quarter is 20. And our trend equation is 28.74 plus 1.84x. Now, we can now have, for the third quarter now, we want to make the sales forecast. Sales forecast for the fourth quarter of the year 2025. 2025. So our trend equation is y equal to 28.74 plus 1.84x. And where x is 20, we said for the fourth quarter of the year 2025, the value of x is 20. You now substitute 20 for x. So we have y equal to 28.74 plus 1.84 times x, and our x is 20. So we have 28.74 plus now 1.84 times 20. That gives us 36.8. So if you add it to 28.74, we have 65.54. So we now adjust. The next thing is to adjust for the seasonal variation. You adjust for the seasonal variation. Now, see, being the forecast says, or says forecast for the fourth quarter of the year 2025, and our seasonal variation for the fourth quarter is 84%. You now calculate 84% of our sales. So we have 84% of 65.54. So 84% of that will give us 55.0536 units. So since all amounts are in 1,000 times 1,000, so we have, that will be approximately equal to 55,054 units. That is our forecast sales for the fourth quarter of the year 2025. Example 2. A retailer sells computers games. Tabulated below are the unit sales of one of its games for the last 13 quarters, together with the computer-generated trend equation and average seasonal variations. For planning purposes, forecasts of sales are required for the remaining 3 quarters of this year. The plan was introduced in 2020. We have the sales for quarter 1, quarter 2, quarter 3, and quarter 4. The sales for the period are given. Trend equations. Trend equation, S equal to 180 minus 10t, where S is sales units and T equal to time period in quarters. For example, T equal to 1 in quarter 1. That is, in quarter 1, you have your T equal to 1. In quarter 2, your T will be 2. In quarter 3 of 2021, your T will be 3. In quarter 4 of 2021, your T will be 4. In quarter 1 of 2022, your T will be 5. Then, quarter 2 of 2022, your T will be 6. Quarter 3 of 2022, we have 7, 8, 9, 10, 11, 12, and 13 respectively. So, T equal to 3 in quarter 3 of 2021, T equal to 5 in quarter 1 of 2022, and so on. Average seasonal variations for the years. We have the quarter 1, quarter 2, quarter 3, and quarter 4. The average seasonal variation for for the years 2021 to 2024 are given to be minus 40%, minus 40% is 0, and plus 80% required. Forecast the unit sales for the second, third, and fourth quarters of 2024 and comment on the reliability of this forecast. B. Interpret the key factors in these games. In this game's unit sales. As is 2021 to 2024. 2021 to 2024. So that is the question. Now, solution. I've told you that to solve problems involving time series, you are going to, the first step is to estimate the trend equation. And our trend equation has been given. The trend equation has been given as S equal to 180 minus 10t. And that is the first step. The trend equation or trend line. Trend equation is given as S equals to 180 minus 10t. That is our trend equation. Since the trend equation has been given, the next step is to use the trend equation to forecast the sales for the required quarters. Now, using the trend equation, we want to forecast the sales for the required quarters. Now, you have to forecast the sales for the second, third, and fourth quarters of 2024. Now, back to the question. Now, remember you were given sales for 2021 to the first quarter of 2024. Now, I've told you that the first quarter of 2021, that is 1. We have 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That means this quarter will be 14. I mean, the second quarter of 2024 will be 14. This one will be 15. The third quarter of 2024 will be 15. And the fourth quarter of 2024 will be 16. Now, we are going to substitute 14 for t in our trend equation. Back to the trend equation. So, we want to forecast sales for the second quarter of 2024. And that we are going to use, and I've told you that we are going to use 14 for the second quarter of 2024. That means our t will be equal to 14. So you now substitute 14 for t in our trend equation. So we are going to have S equals to 180 minus 10 times t. And our t is 14. So we have 180 minus 10 times 14. And that will give us 140. If you now have 180 minus 140, and that will give us 40. That is our sales for the second quarter of 2024. So, in this sales, we are going to adjust for the seasonal variation. We are going to adjust for the seasonal variation. Remember, we want to estimate the sales for the second quarter of 2024. And since it falls within the second quarter, back to the seasonal variation. The first quarter, the seasonal variation is minus 40%. The second quarter is minus 40% as well. So we are going to adjust for that. Now back to the solution. We have our sales will now be 40 multiplied by 1 minus, since it is minus 40%. Since it is minus 40%, our seasonal variation, since it is minus 40%, that is why I have minus 40%, which is 0.4. 40% is 40 divided by 100, and that is 0.4. So we now have 40 multiplied by 1 minus 0.4, that will give us 0.6. If you have 40 times 0.6, that gives us 24. That means the sales for the second quarter of 2024 will be 24. Now, the next thing is to determine the sales for the third quarter of 2024. We want to estimate the sales for the third quarter of 2024. Sales for the third quarter of 2024. 2024, our T will be 15. For 2024, our T will be 15. So we have T equals to 15. Remember, the trend line or the trend equation is S equals to 180 minus 10T as given in the question. S equals to 180 minus 10T. Where T equals to 15. So we have S equals to 180 minus 10 times 15. So we have 180 minus 150. 10 times 15 will give us 150. If you have 180 minus 150, that will give us 30. Our S equal to 30. The next thing is to adjust for the seasonal variation. Now let's adjust for the seasonal variation. Remember, we want to estimate the sales for the third quarter. And the seasonal variation for third quarter is 0. Since it is 0, we are going to, our S now, our sales now, will be equals to 30 into 1 plus 0. So which will be 30 multiplied by 1 minus 0 or 1 plus 0. Whether you use minus or plus, since it is 0, it will still be 1. 30 times 1, that will be 30. That means the sales for the third quarter of 2024 is 30. Now, we want to estimate the sales for the fourth quarter of 2024. So, the fourth quarter of 2024, T will be equal to 16. Remember, the trend line is given as S equals to 180 minus 10T. Where T is 16, then you have 180 minus 10 times T, and our T is 16. So we have 180 minus 10 times 16, and that will be 160. So if you have 180 minus 160, then we have 20. Therefore, S equal to 20. Now, we now adjust for seasonal variation. Adjust for seasonal variation. Now, you know, this is the sales for quarter 4 of 2024. And in the fourth quarter of the year, the seasonal variation is plus 80%. Plus 80%. Therefore, the sales will be equals to 20 into 1. Since it is plus 80, then that means you are going to use plus 80%, which is 0.8. 80 divided by 100, that will be 0.8. So you have 20 into 1 plus 0.8, that will be 1.8. 20 times 1.8, then we have 36. That means sales for the fourth quarter of 2024 will be 36 units. The sales will be 36 units. Back to the question. You were told to forecast the unit sales for the second, third, and fourth quarters of 2024, and which has been determined. The unit sales for the first quarter and the second quarter of 2024 is 24 units. The unit sales for the third quarter of 2024 is 30 units, and the unit sales for the fourth quarter of 2024 is 36 units. Now, You were also asked to comment on the reliability of this forecast. You have to comment on the reliability of this forecast. If you look at this question, you were given the sales for the first quarter of 2021 to the first quarter of 2024. So that means you are given sales for 13 quarters. And you have to comment on the reliability of this forecast. Given a long-term trend, it is likely that the forecasts are reasonably reliable. Given a long-term trend, since the trend is very long, that is from the first quarter of 2021 to the first quarter of 2024. So it is likely that the forecast are reasonably reliable. That is the answer to that. Back to the B aspect of the question. You are to interpret the key factors in this game's unit 6. That is for 2021 to 2024. You are to interpret the key factors in this game's unit 6 for 2021 to 2024. If you look at the sales given from the first quarter of 2021, the amount given are very large. We have like 150, 120 and so on. But if you look at the second quarter of 2024, the sales was obtained to be 24 units, which has now deteriorated. It has reduced so much. And if you look at the third quarter of 2024, it increased slightly to 30 units. And the fourth quarter of 2024, it increased slightly to 36 units. Given the reliability and the consistency of the trend and seasonal variations, given the reliability and the consistency of the trends and seasonal variations, the sales position for the brand looks very bad. The sales position for the brand looks very bad. Please don't forget to like, share and subscribe. And if this is the first time of you coming across the YouTube channel, please click the red subscribe button and also turn on the notification bell icon so that you don't miss my upcoming videos. If you are a returning subscriber, I say thank you and God bless you. Hooray!